All right, welcome once again to my YouTube channel. Today in this episode we are solving motion, physics question under motion. So let's read the question together. A car accelerates uniformly from 8.3 meters per second to 13.8 meters per second within a distance of 60 meters. Calculate correct to the nearest second the time it takes to cover this distance. So how will you address this? This is wire question, also likely jam question. So now, before you solve, you write your solution and list your parameters. Initial velocity 8.3 meters per second, final velocity 13.8 meters per second, distance 60 meters, time is what you are looking for. In this type of problem, you are advised that you should know the equations of motion. These are the four main equations of motion. You should know them thoroughly. So as you see questions, write all of them down and check them against the question parameters, the parameters given in the question. Which of them is appropriate to be used? Looking at it, we have initial velocity, final velocity, distance, and time. So look at this. Which one can we use? Is it equation 1, equation 2, equation 3, equation 4? Which one can be used? So looking at the parameters given, initial velocity, final velocity, distance, and time, I think the first equation should be used here should be equation 4, the easy and the simplest, because of the information given. The easy and the simplest to be used. You can use others, but let's use 4. 4 is the most appropriate to be used, the average distance. That's what the average distance. So when you have that, you make t the subject. Making t the subject means you multiply through by the LCM, which is 2. So 2x over v plus u is equal to t. Substitute the values into that, you get your value, your time to be 5.43 seconds, which is approximately 5 seconds. That is the simplest formula to use over there. But that's number 4. This particular equation of motion, most students don't really use it. Now let's see students who want to use equation number 3, because the same parameters are given: velocity, final velocity, initial velocity, acceleration is given, distance is given, so we can find acceleration from equation 3. So rearranging equation 3 to find the acceleration, which is equal to final velocity square minus initial velocity square all over 2 times the distance or the displacement. So 13.8 square minus 8.3 square giving us 190.44 minus 68.89 all over 120. When you subtract that, it gives you 121 point something divided by 120. It gives us the acceleration to be 1.01 meters per second. So when you do that, you have your time. From there, then you can also go and pick equation 1 from the top, making t the subject in equation 1. You have v minus v minus u all over a. So that gives us 13 minus 8 all over. If you recklessly approximate the acceleration to be 1, you are likely to get the time to be 5.5. If you get the time to be 5.5, you are likely to approximate it to 6, which you will not get your answer. So you need to be more accurate in this calculation. So when I use velocity, acceleration is equal to 1, I get the time to be 5.5. But when I change it and use the correct value of acceleration, which is 1.0129, I got the time to be 5.43, as I have gotten in using this equation, using equation 4. So now I recalculated it again and I got the time to be 5.43 seconds, which is approximately 5 seconds. If you do reckless approximation or immature approximation, you are likely to get a reckless answer. I hope you pay attention to this detail. Thank you very much for watching. Like, comment, and share. So with this, you can now say that your answer is what? Your answer is C. You can proudly say your answer is what? C. Thank you very much for watching. Like, comment, and share.